Welcome to the shop. I'm continuing NQALHA Production Run 4, making 750 parts. That's a lot of parts, so I better get going. Before I start today, I'd like to take a moment to thank all of the people on YouTube, which I call the University of YouTube, all of the people who share their knowledge. They're an inspiration and a very useful resource. So let me show the t-shirt here, one of my favorite YouTube channels. When I started learning machining in 1967 in junior high school, the only resources available were the shop teacher, a very few books, and an even smaller number of 16mm educational films. The amount of information available today is really astounding. I love watching experienced machinists like A-Bomb or Tom Lipton with 40 years of experience in metalworking, showing little tips, little tricks, how to do high precision work, how to avoid making mistakes. And it's not just machining. I've been watching blacksmithing, glass blowing, clock making, boat building, woodworking. It's an amazing resource, and it inspires me to try to add my own little bit, and hopefully someone will find the stuff I do interesting. So in today's video, I'm going to finish up the little parts made in the made two at a time and with the gang idea. I've got, this is going to be not a very interesting little part, but it's a necessary little part. The only thing interesting about it is that most of the material gets milled away, and figuring out how to actually hold it becomes a tiny bit of a challenge. But after this is done, I'm going to move on to drilling some holes in the laser cut steel parts, and then move into some of the more different stuff using the Tormach rapid turn CNC lathe attachment, using my manual metal lathe, and I'm nearing the end of this very, very long process. So the first operation on this guy is another totally boring one hole. So hopefully it'll go right the first time, but that's what I always say. Software can make you crazy. Single block mode. Looks like it's stopping in a reasonable, sane place. .5140 RPM, 10 inches per minute, fast peck, 50 thousandths per peck. Wrap it over to the right side, drill that hole. All is well. I'm going to turn the cameras off, run this batch, and this part will be made in 3 operations. This is a little part that it's probably a part that nobody even notices when they look at the NQALHA. It's a little kind of like right angle wire cover that kind of protects the wiring in the cable harness as it makes the U-bend. Without it, the wires tend to get looser and looser and fall out and look messier and are in more danger of being snagged on something, and this fixes the problem completely. So see you later. First operation has been completed. Got the parts in place for the second operation. And I gotta keep talking about YouTube. Not only are there videos of craftsmen and craftswomen demonstrating their craft and sharing all their secrets, but there's also a world-class physicist giving graduate level lectures, world-class mathematicians, historians, biologists, chemists. It really is the new university, and I'm really proud to be part of it, and I hope that some people find my contributions useful. So, gonna be taking out some material here, taking out quite a lot of material, using a 1/2-inch end mill with the parts held securely in place. That's one thing about the gang operation. Let me stop talking while I'm working, because we all know what happens if I talk too much and don't pay attention. That looks fine. Actually, let me check. Doing the gang operation not only speeds up the work, but it equalizes the force on both sides of the vice jaw, which is, good practice in general. It's a good practice to use a piece of scrap on the right side if you have a tiny piece on the left side, even if you're not making two. Going slow, taking, how many passes? I think 3 passes. Don't want to get too aggressive on this. The piece that remains is slightly under 100 thousandths. So I'm just being slow and being careful. And boy, that 1/2-inch cutter throws a lot of coolant everywhere. So that looks completely successful. All is well. Gonna turn off the camera, run this batch, and come back for the 3rd operation, and then set up the machine for drilling some laser cut steel parts. The steel plates and the plates in the NQALHA are what the magnets stick to. Obviously, electromagnets need to stick to steel. And my local metal, not local, but my metal supplier has a couple of very nice high-speed laser cutting machines, and they produce the blanks at extremely reasonable cost. I was actually shocked to see how inexpensive it was. And when I compare that to milling them out of solid steel on the machine, there's no question. The laser cut is a far better way to go. So for those parts, they go real quick. All I have to do is drill a few holes in them because they're pretty much already made. And that's what's going to be coming up after the 3rd operation. So I'm going to turn the cameras off and come back later. 2nd operation has been completed. Time to move on to the 3rd operation. And I thought it would be a good time to talk a little bit about philosophy here. This part is a rather interesting part to make. It's a small part with not much material left after the machining operation, and the challenge is to figure out how to hold it, how to put it in the vise, how to hold it for machining. And it brings up a topic that is a kind of an important topic to me, and that is, since I'm the inventor of the machine, the designer of the machine, I program the tool path and then run the parts, I have an insight into the entire process that is difficult to do in a larger organization with more finely focused specialists, with engineers, designers, production engineers, industrial designers, where the entire design and all of its details don't fit into a single mind, or maybe the different divisions don't communicate well or try to keep secrets or play politics with each other or whatever. Reminds me of an interview I saw with the director Robert Rodriguez, who's kind of rare in the film industry, where he's the writer, the director, composes and plays the music, does the editing, and operates the camera. And he says, oh, while I'm shooting, I know what scenes I'm going to use because I'm also the editor and I kind of see the movie in my head while I'm shooting. Well, when I'm designing a part, I'm designing the part and thinking about, can my machine make it? How do I hold it? What kind of material is it made of? Can I buy the material locally, or do I have to order it from some very expensive faraway place? And I think that gives me a tremendous advantage. Obviously, you can't build a commercial airliner that way. Some projects are just too big for one person, no matter how talented the person. But for the projects I do at the scale that I do them, I think I have a great advantage because I do it all. So, enough rant, let's make some parts. Once again, semi-known trusted toolpath. The gang version has never been run before, but the single version was run. And that looks correct. Once again, going very conservative because there's not much part left after this operation gets done. And even though it's an aluminum part held in aluminum soft jaws, yeah, I gotta make sure that I've got enough rapid clearance so I don't knock the top. Oh, there we go, okay. Aluminum against aluminum has a very high coefficient of friction, and an aluminum part held in aluminum soft jaws is a pretty securely held part. But still, it's not held, there's not a whole lot of clamping force, or I should say there's not a whole lot of clamping distance going on there, so I'm taking it easy. Certainly don't want to ruin the part at this point. So, there we go. Operation completed totally successfully. And there's the little guy. So I'm going to run the rest of the batch and set up for drilling the steel parts. And little bit by little bit, the project is nearing its conclusion. So that's good. I like finishing things. See you later. I finished the third operation on these little parts, and that's the last of the little parts. Sure glad that's over. Now it's on to the steel parts. The steel parts are laser cut. Here's an example. Laser cut out of 1/8 inch steel plate. And some of the features, like this large clearance hole for the bearing, are cut with the laser. Other features, like the 1032 tap holes and the countersink 1032 clearance holes, I drill those on the mill. So I've got a combo tool path set up here, drilling two different parts, work offset 1, work offset 3, 0 on top of the tooling plate. The tool paths are known and trusted, but I kind of combined them together, kind of intertwingling, to minimize tool changes. And so that's never been tested before. Hopefully everything goes well. But things are starting to get fast now. This goes really quick. I can see the end is near. Well, not that near. There's still some very time-consuming stuff coming up. So that looks correct. That looks kind of stupid. That extra little move up and down. Looks like I have sufficient clearance to get over the hold downs. That's all looking pretty good. That weird little Z move is kind of odd. Looking right, looking kind of right. Bobcat puts in some fairly surprising little Z moves. Sometimes it does what I expect, sometimes it does what I don't expect. Now I'm moving over to avoid a tool change here. Moving over with the same drill. This is the number 9 drill, the 1032 loose clearance hole. Interesting that got a different spindle speed on that one. Yep. Got to have a spindle stop before the tool change. I don't know if the control software is smart enough to figure that out, or if it would just go ahead and leave the spindle running while it was changing tools. I don't know about that one, but I'm going to go fix it anyway. Editing G-code by hand is not really that hard, but it is just a tiny bit scary. So I'm going to run the whole thing over again, just to see if I've cleaned up some of the weirdness. Didn't get that. I didn't get that one. It's a kind of a mystery to me why Bobcat throws in that kind of little Z. It's like down, up, and then what's going on there? But hey, are we having fun yet? Hopefully this is a little more sane. And no, that would be completely wrong if it did what it's going to do next. Oh. Just trying to be a little extra careful here. It seemed to have worked correctly the first time. I really don't want to run the tool. Yeah, that would have totally run the tool into something bad. So hand editing G-code, my least favorite thing. Since I use toolpath for almost everything, I'm not a extremely proficient hand editor of G-code. I'm going to run this one without the part in place. Of course, I may be wasting more time doing this. I may be wasting more time doing this than I'm saving, but yeah, modal peck drilling. I believe that it actually was correct. But it sure looked weird bouncing up and down like that, but it's... Oh, this stuff's gonna make me crazy one day. Well, I already am crazy, so. Yep. Well, you can probably imagine what this is going to look like when I get it debugged. I'm going to turn the cameras off and go try to figure this out. There's some modal stuff going on in the G-code that I don't fully understand, and I'm getting anti-intuitive results, but it's probably just because of my limited familiarity with hand editing G-code. So, after spending way too much time dicking around with that G-code editing by hand, I think I have it working reliably now. And yeah, I probably, in the grand scheme of things, if I just used my old toolpath, I would have been done by now. But I did learn a little bit, got a little more familiar with hand editing G-code. So, hey, no problem. I'm going to tap these holes by hand later because they're real fast and easy to tap by hand. They don't have to be precisely straight, and it saves the tool change. I'm not as experienced working with steel as I am working with aluminum, and I find that whenever I try to get too aggressive with steel, I start breaking cutters and burning up cutters, and I got a lot to learn about getting maximum performance in steel, but for today, I just go slow. 5 inches per minute feed. 2,800 RPM on the number 9 drill. In aluminum, I'd be running that drill at 5,140 RPM. And 10 inches per minute feed. So now comes the countersink. This is a solid carbide countersink, and I've been experimenting with feeds and speeds to try to figure out how to avoid chatter and get a nice clean hole. I still get a tiny bit of chatter. I haven't perfected it yet, but this is going to be 2,000 RPM, 1 inch per minute, and little bit of chatter. Still working on trying to perfect it. Makes a nice hole. The countersink hole, the result comes out just beautiful. But I have no doubt that there's much to learn about machining steel for highest possible performance. Good thing I don't machine a lot of steel. Stainless is even worse. Good thing I don't machine a lot of stainless. But, of course, like everything, if I had a project with a lot of steel, I'd learn how to machine steel. I typically learn what's necessary for the project to get it done, and in this project there's very little steel. May also be that just the nature of the Tormach, when working with steel, you gotta run slow. Now I'm drilling a 5/16 hole, and I want the hole to be a pretty accurate hole, so I'm drilling the first hole is going to be a 64th under, and then I probably could ream it, but I don't have a 5/16 reamer chucked up. I do have a 5/16 end mill, and it makes a beautiful clean hole, taking out that extra 64th. And it works perfectly, so reamer or end mill, I don't know, the end mill just works fine. So that does it for those parts. And yes, I did verify the countersink depth with a screw. The countersink on these guys is kind of, not super critical, but kind of critical. I don't want the screw protruding above the surface because the magnet assembly is going to be kind of sliding around, and it doesn't slide right on the surface, but still, it's nice to have the surface flush, and it is. So I'm going to run these parts. I have a couple of more steel plates to do, and I probably won't show those because same operation, just slightly different looking plate. So thanks for watching. The next video is going to be making the drive wheels, and there are 80 of them. Each NQALHA has 8 drive wheels, and the drive wheels will be roughed and drilled on the Tormach in a gang operation, and then finish turned on the rapid turn. So anybody that's interested in seeing how the rapid turn works, well, next video is the one for you. So thanks for watching. It's been mostly fun and a little annoying.